Good day, this is Shane from IVEK Corporation, and I'd like to spend this short video describing to you the Electrospense 23 dispensing system. It is an all-in-one pump with multifunction I/O and the ability to function between 12 and a maximum of 24 volts DC. As you can see, I have a cheat sheet back here showing what the I/O does and how it can be wired. This pump is capable of utilizing our 1A, 2A, or 3A ceramic piston cylinder sets, which can provide a max displacement of 27 microliters for the 3A, 54 microliters for the 2A, and 109 microliters for the 1A. That is max displacement per revolution. A system that arrives to you will have a displacement head on it, and also a pump, of course. I've removed that, so when we get into functionality, you will be able to see this spindle move. On the reverse is where all the connections are made for the system. We have our plus and minus for voltage supply, 12 minimum, 24 volt maximum DC voltage. We have two diagnostic LEDs here, labeled 1 and 2. One can be green, flashing green, red, or flashing red, and that is strictly for the voltage supply, whether it is in range or out of range. 2 is also green or red, and that is the attention state, or what we may consider a fault state. So if both lights are green, we're in a good condition. Next, the orange connector, which would be called multifunction port A. Pin 1 begins on the left side, pin 7 on the right. On the side of the casting here, this is labeled A on the top, followed by a 1 designated pin assignment, and then B for the blue on the bottom. So blue would be your multifunction port B. These remove quite easily, and both are keyed. So as poka-yoke, only one type of connection can be made. The blue cannot make connection into multi-port A, only into B. Next we have RS-422 input, and that is for the initial programming of the system, and also any user variables that may want to be changed can be done through this port. When this pump is ordered, a customer is required to provide data based on this sheet here, which is a customer application setup. It designates customer, order number, and all information that IVEK would require to set this system up. Everything on this sheet here can be changed by the customer, but will be pre-configured from IVEK. So when you receive this pump, it will be a matter of supplying voltage to it and installing proper I/O that you would like to use, and you're on your way. So for this test, I'm simply using a 24 volt co-cell power supply. I have model PBA30F, which is a 24 volt 1.3 amp supply. I have it pre-wired simply by installing my positive and negative supply voltages and tightening down. That would install here, and then tighten as necessary. And then we have multifunction port A. Install. So what we have here is pin 1, are we syncing or sourcing the voltage? If we are syncing the voltage, we are providing positive voltage into this pin, and we're going to be syncing it to ground. If we are sourcing the voltage, we'll be using the negative, and we'll be pulling that negative up using the plus. So in this case, again, I'm syncing. I have positive voltage going into pin 1, and here's my sync source. Pre-configured from IVEK, the next pin, pin 2, is dispense. The next one is meter or prime. Pin 4 is a reference to get the pump into the proper location. And pin 5, forward reverse. If this is tied in to sync or source, it will go to reverse. Otherwise, it is defaulted forward unless otherwise noted in the customer application setup. Pin 6 and 7 are analog inputs. For example, if you choose 0 to 10 volt analog control, when you provide anywhere from 0 to 10 volts on these final 2 pins. That will adjust the speed based on the max speed designated by you, the customer. This can also be configured for milliamperage as well. Voltage is 0 to 10, amperage is 0 to 20 milliamps. Multifunction B, I do not have wired up, but I want to cover that as well. Multifunction B, IVEK presets pins 2, pins 3, 4, and 5. Pins 2 and 3 are the ready output. So anytime the system is in a ready state and is awaiting a signal such as dispense or a meter, it will provide a true signal to ready out. And I have a quick example of just wiring up a lamp here for testing. Another useful part of the fault condition is we will see it on the diagnostic LED on pin 2 as well. So let's get our multifunction A wired back up. So as you see here, I have blue for dispense, red for meter, yellow for clear and reference, and green for forward and reverse. Pay attention to the lights. So my voltage is good and I do not have a current attention state. So the system is happy. So the first thing I want to do, I have a positive source, so I'll be syncing my voltage. I'm going to pull pin 4 to ground so I can get my piston into the proper place. So as you can see here, this is in a 9 o'clock position and is now ready. If I keep the IO active, it will simply just do its one cycle. So now if I move to the red, which is meter, for example, if I want to prime the system, we should see the system begin to prime. Notice it's going in a forward motion, which is clockwise. Now also take note, when I complete the cycle, it simply stops the motor wherever we release the signal. With that being said, I strongly recommend sending back home on pin 4. Now let's do green, forward, reverse. So the system by default is forward, so I'm going to tie my green, pin 5, which is forward, reverse. I'm going to sync that to ground so that now I'm in reverse. And I'm going to use the red, pin 3, to meter, and we should see it meter in reverse. Counterclockwise, reverse. Forward, clockwise. And home. And my dispense on pin 2, which is blue. Notice it's preset for a different speed, and it's going to conduct the dispense dependent on the programming, which could be anywhere from 0 to 10,000 strokes. One more thing I would like to cover quickly is the ability to test the I/O. I'm going to do this using a multimeter, and I'm going to do that checking amperage. So I have my negative to common on the multimeter, and I have my positive in the milliamp range. In this case, this can handle up to 400 milliamps, which is more than enough. So I'm going to go over to my DC milliamps, and I'm going to tie my negative lead to the negative lead of the power supply, and my positive lead I'm going to tie to my I/O. So let's say clear reference. So as we can see, when I clear a reference, I'm pulling approximately 8 milliamps from the system. When I meter, again, approximately 8, in this case 7.4, 7.5. So now let's stack the two and let's do a reverse input and a meter. So we're doing 2. So in theory, we should have anywhere from 14 to 16. And there we have 14. So this is a good way to test your I/O, because we know we're pulling about 7 milliamps per IO. So forward reverse is functional. Of course, the meter is functional because it simply turns the motor. Clear and reference, same. And dispense, same as well. If we do not see any amperage here and the system is not turning, then most likely we have a fault with the IO inside the system. Finally, I'd like to cover the serial programming of the Electrospense 23 dispensing system. So I have a cable with a 9-pin female connection that will simply plug into the Electrospense. And on the other end of the cable, I have a 9-pin serial adapter to USB. This is an RS-485/422 output converter. I'm going to install that into a compatible USB slot. And I am using a third-party terminal emulator that is also freeware called CoolTerm. So I'm going to find that I am on COM4. I've pre-configured my settings. 9600 baud, 8 data bits, 1 stop bit, no parity. DTR RTS is off. Okay. I'm going to connect. And at the bottom I see the status that COM4 is connected. EX space PV. What that's saying is display all variables that the user has control of. So we have our inputs and what state they're in, and then we have the user variables. These are most common what may want to be changed. So for example, our dispense volume. Let's say we want to change that to 1 stroke. V0 equals 1. So I have an echo here, but I don't know that it's truly changed to 1. So simply EX space PV, enter. And we see our dispense volume is now 1. So when I activate my IO on the Electrospense multifunction port A, I'm going to get 1 dispense revolution. I can change my rate type. So will I be controlling it through the program here, or will I be controlling it with 0 to 10 volts, or will I be controlling it with 0 to 20 milliamps? So to change that, for example, I would simply type in Y9 equals, and then 0, 1, or 2, based on my choice. The default right now is 0. Thank you for watching. If you have any further inquiries, you can reach IVEK at 802-886-2238, or you may find us on the web at www.ivek.com.